It is a math question asked by a primary 5 student. Which of the following numbers can be divisible by 6? Okay, you want to use the phone call?
Hi, Jane. I want to ask you a question.
I'm not Jane. I'm her husband, John.
Sorry, John. Can you give the phone to your wife and I want to ask?
As a primary 5 student, how can you... never mind. Do you want to use 50-50? Okay, only 2 left. Do you have the answer or you want to ask the audience? I think most people have had a bad experience with mathematics because sometimes you really don't know how it works. We have all faced problems like large numbers, number operations, perimeter, area, and volume. Sometimes these concepts are quite abstract. In today's video, I'm going to challenge you. Do you think you can pass primary school math? I bet you can't.
Primary 1. Subtraction.
If you are a parent with a child who is 5 or 6, you will find that they have no problems with addition. However, once they start subtraction, the disaster strikes. Let me show you how students make mistakes in subtraction. For example, 13 minus 6. First, they need to hold up 6 fingers, then move them one by one to count. Next comes to the most challenging part for the students. Should I start from 13 or 12? We can easily understand this by using a number line. We can break down 13 minus 6 into 6 steps of minus 1. The first step is 13 minus 1, which equals to 12, and that should be the first number to count. However, a 5 or 6-year-old student doesn't understand why she can't start counting from 13. Especially when doing other exercise, they become even more confused. In this exercise, you need to write down how many ducks are fewer than chicken. Of course, some students may only count how many chickens left and get the answer. But some students get the answer by doing subtraction. At this point, they clearly see that the chicken starts counting down from 15 and get the answer, so that they may confuse why this time doesn't need to count from 14. To be honest, I know that some high school students also have the problems with subtraction. They exactly use their fingers to count.
Primary 2. Multiplication.
I think most students are quite familiar with this table and it's also one of the biggest challenges to primary school students. Multiplication table. Look at the homework. If you cannot memorize the table, you may not finish them quickly. Finishing homework quickly means you have more time to play. Therefore, students only accept this robotic mission reluctantly if they want to play. However, humans are not computer. We cannot memorize all the things correctly. I had an experience which is a Form 1 student argued with me about her homework. She insists that 8 times 9 equals 64, and I told her 8先係64咯. That was so embarrassing for her because the other students heard about it and started to laugh, and I saw her face turn red. So I comforted her and said, remember, 8964 is not your fault.
Primary 3. Mixed operations.
It is a table of the primary 3 math syllabus. As we can see, the students need to learn 15 units in the first semester. Do you notice how many units are about arithmetic? There are 7 units. Our students spend half of the semester doing arithmetic. If this homework is a love story, the love is a full page without any spaces. The love story continues into the second semester. And look at the first 3 units. Does our government lack calculators? Why does it emphasize arithmetic so much? And guess what? Comparing fractions? As a primary 3 student, I know that you can do it in 3 seconds. Which one is greater?
Primary 4, it's again for arithmetic operations.
Yeah, I absolutely agree the primary 4 math syllabus is just an upgraded version of the primary 3 math syllabus. They really want to train our students to be calculators. Look at the first 6 units. Our students continuously practice arithmetic this year, but this time they need to learn some tricks first. This is a typical question and every primary 4 student can do it quickly. 32 and 18 are multiplied by 6 at the same time, so you can add 32 to 18 first, then multiply 6 to the sum. Through this property of multiplication, our students have been trained to achieve a superpower, mental calculation. Find the answer in 5 seconds without using calculator. I know some of you may be wondering,
how can a person calculate the multiplication of 2-digit numbers so quickly?
and I'm going to tell you, we are well trained with these types of number after completing 100 or even 1000 practices. And guess what? We have also been trained in another ability. No matter how large the number is, we know what it can be divisible at once. I think there are some reasons why the government is training our students in this way. They only want the students follow the rules. I still remember my parents bought me a stack of homework one summer, and that was the first time I learned the word stack. I believe some of you may also experience the boring level of summer homework. It is completely different from regular homework. It just involves repeating arithmetic over and over with no space left on the entire page. And that's just the first semester. The second semester is the real challenge. All of these units focus on how to calculate fractions and decimals. I just want to know, when was the last time you calculated with fractions and decimals? Or, as a normal person, do you do this without using a calculator? I think you won't.
Primary 5, perimeter and area.
After the tough time in primary 3 and 4, our students had already lost their passion on learning. In the past, I tried my best to motivate them, but they didn't show any curiosity. I still remember I prepared a lesson about perimeter and area for primary 5 students. I knew they often confused these two concepts, so I asked them to draw a picture on paper and design their own phone case. I thought it was a great idea because they would be excited to create their phone cases, while I could teach them the differences between perimeter and area. However, no matter how much they enjoy designing their phone cases, they were so upset when they realized they had homework. I really sensed their frustration about doing so much homework and all they want to know is just the formula, a cold, impersonal instruction which allowed them to finish their homework quickly. I really want my students to understand the concepts rather than simply memorize the formulas. So I told them I wouldn't mind if they counted the perimeter side by side. However, they denied it because they just wanted to get the answer as soon as possible.
3 weeks later.
There was a math test a few weeks later, and one of the questions was find the perimeter of triangle ABD. And guess what? Some students answered it 42 cm. Not only one, but at least 4 students answered the same wrong answer. Then I realized they might count it in formula of a rectangle. Are you the same type of person as my students? They just simply memorize the knowledge without trying to understand. Therefore, I want to challenge you. Do you know how to get the formula for the area of a trapezium?
Primary 6, volume.
In recent years, I observed that teens have developed a fast culture. Not only fast food, but also in their entertainment, even in the knowledge. It is a primary 6 math question and it asks how much does the water level drop after taking away all the bits. I would like to teach them in 4 steps. First, we need to count what the original volume of the water and bit is. Then, taking away the bits means minus the original volume by the total volume of bits. Next, we can find the height by divisible the base area. Finally, the dropped level is the original height minus the new height. After I explained all of this, I realized some students had already slept in the class, and the others started to challenge me. 喂，阿 Sir， 書入邊唔係咁教嘅喎。To be honest, I could follow the textbook and ask them to finish all the questions with the formulas. But that's meaningless. I spent so much time to write the whole things because this equals the so-called formula in textbook. It is the formula the students want. They didn't care about how to get it. They only cared about the answer. To be more specific, they only cared about their grade. Sometimes I ask myself, do these scores really reflect how much knowledge the student has gained? Maybe it's just about how much formulas they had memorized.
The area of parallelogram is base times height. We can cut it in half and get two trapeziums. The sum of the upper base and lower base equals the original base of parallelogram. That's how we get the area of trapezium.